Why 34 was the best tank of World War II? Let's find out today. The T-34's development was a masterclass in wartime engineering refinement. Derived from early Soviet chassis experiments, engineers optimized the design by integrating a Christie suspension system, enabling superior cross-country mobility with a top speed of approximately 53 kilometers per hour, and a compact 500 horsepower diesel engine that balanced power with reliability. Its signature sloped armor, with 45 millimeters angled at 60 degrees, wasn't merely for weight savings, it effectively increased the plate's ballistic resistance, a critical countermeasure against contemporary German anti-tank weapons. The 76.2 millimeter F-34 gun, calibrated for a blend of rapid-fire capability and armor penetration, outpaced the shorter-barreled armaments of the Panzer IV and the constrained firepower of early M4 Shermans. Each design decision, from the wide tracks reducing ground pressure to the streamlined hull, addressed specific battlefield challenges, ensuring that the T-34 wasn't just innovative but a decisive factor in mechanized warfare. The hull's 45 millimeter rolled homogeneous steel, angled at nearly 60 degrees, yielded an effective frontal thickness approaching 90 millimeters, crucial for deflecting high-velocity impacts. The turret, compact and curved, initially featured 45 millimeters of armor, later upgraded to 90 millimeters on T-34-85 variants, minimizing target exposure while maximizing structural integrity. Seamless interlocking welds reduced weak points, as verified in declassified Soviet testing against German anti-tank rounds. Internally, crew ergonomics were optimized under extreme spatial constraints. The driver's station, shielded by a low-profile glacis, ensured maximum forward visibility, while the command, gunner, and loader positions were arranged for rapid communication and operational coordination. This tightly integrated design provided a balance of mobility, survivability, and production efficiency that defined the T-34's battlefield success. The heart of T-34, the V2 diesel engine-powered tank with a robust 500 horsepower at 1,600 revolutions per minute, delivering approximately 1,470 Newton-meters of torque. Its 38.8-liter displacement was optimized for fuel efficiency, critical for extended operations in harsh environments. The 5-speed manual transmission, paired with a reduction gear tuned for low-range torque, provided rapid gear shifting under varying terrain stresses. Suspension design featured torsion bars combined with wide, low-pressure tracks, ensuring exceptional off-road adaptability and shock absorption. This integration allowed the T-34/76 to reach top speeds near 53 kilometers per hour, with acceleration enabling swift tactical maneuvers in rugged combat zones. Field reports confirm that these design choices, balancing power, reliability, and cross-country mobility, were instrumental in the T-34's operational success, even under the unpredictable conditions of the Eastern Front. As to armament, the T-34's main gun epitomizes battlefield efficiency. Early models mounted the 76.2 millimeter F-34, firing AP shells at 680 meters per second with a rate of 4 to 5 rounds per minute. Its 6.6 kilogram rounds reliably penetrated 45 millimeters of armor at 500 meters. Upgraded T-34/85 variants adopted the 85 millimeter D5T, boosting muzzle velocity to roughly 800 meters per second. Its heavier 8.2 kilogram shells dramatically improved penetration against thicker, newer armor. Alongside these primary cannons, a coaxial 7.62 millimeter machine gun provided close-range defense. The design optimized ballistics with fixed mounting, reducing barrel heating during sustained combat, while integrated fire control systems, albeit rudimentary, combined with intensive crew training for rapid target acquisition. This precise engineering, underscored by declassified combat data, not only elevated the T-34's lethality, but also shaped its tactical employment on the Eastern Front. Optical sighting systems formed the backbone of the T-34's targeting suite. Early models relied on fixed periscope-style range-finding, simple yet rugged, with reticle adjustments calibrated for 500 to 800 meter engagement ranges. Later upgrades incorporated improved glass optics in the commander's cupola, marginally enhancing target acquisition accuracy. Radio units, such as the R113, were sporadically fitted. Their analog circuits offered 5 to 7 kilometer communication ranges, though reliability suffered from battlefield EMI and environmental stress. Crew protocols emphasized visual verification and pre-planned maneuvers to counteract these limitations. These integrated, albeit rudimentary systems allowed for coordinated fire missions despite inherent signal dropouts, a critical adaptation on the fluid Eastern Front. The T-34's defensive genius lay in its meticulously engineered passive armor. Structural vulnerabilities at welded seams were mitigated in later variants through interlocking armor panels and side applique reinforcements, crucial during sustained combat engagements. Internally, the tank featured compartmentalized critical systems. Fuel, engine, and ammunition were isolated to curtail cascading damage from penetrative hits. Crew safety was further enhanced by reinforced bulkheads and segregated crew compartments, ensuring that localized breaches rarely resulted in total operational failure. These integrated safety protocols and damage control measures, verified through declassified combat reports, significantly boosted crew survivability and prolonged battlefield endurance. In Eastern Front operations, T-34 units exploited the tank's design to dominate open fields while grappling with urban complexities. Field data from declassified Soviet reports show that its top speed and low profile enabled rapid repositioning and effective hull-down tactics. However, in congested urban warfare, its relatively bulky turret and limited traverse reduced situational flexibility, exposing vulnerabilities to ambushes and close-quarter assaults. Crew after-action reports highlighted the diesel engine's durability under extreme conditions, yet noted maintenance challenges amid relentless combat tempo. Despite these urban limitations, operational statistics from 1942 to 1945 indicate T-34 formations secured a kill ratio exceeding 2-to-1 against German armor, underscoring its strategic impact as a stalwart of Soviet armored doctrine. Streamlined for mass production, the T-34 set new benchmarks in wartime logistics. Its design was ruthlessly simplified. For instance, the 76.2mm F-34 gun was reduced from 861 to 614 parts, and early turrets were replaced with a cast hexagonal model, cutting production time and unit cost from 269,500 to 287,700, 135,000 rubles within 2 years. Factories across relocated centers like Nizhny Tagil produced over 57,000 units by 1945, with assembly lines running double shifts even under severe manpower shortages. This production efficiency translated into exceptional operational availability, as the T-34's simplified systems allowed faster repairs and easier field maintenance, despite early mechanical teething problems later remedied by cyclone filters and improved clutches. Economically, its mass production freed critical resources and spurred an industrial mobilization that sustained the Red Army's numerical superiority. By war's end, T-34s accounted for more than 55% of tank output. In essence, the T-34 was not merely an armored vehicle. It was the backbone of a scalable war economy that transformed Soviet wartime mobilization. But the T-34 didn't just win battles. It won the war.